Alright, so today we'll be talking about circles and arcs. So let's start talking about quite a bit. Okay, so the center of the circle, now obviously the definition of a circle is a figure whose sides are all the same distance from a center point. So that's what we've talked about before. Okay, but we want to start talking about some actual stuff with the actual circle. Okay, alright, so if I draw a line, and we would call this a chord, right through the middle, okay, and it connects to the other side, that would be what we would call a diameter. Okay, so diameter, checked it off the list. Alright, now diameter exposes it into two semicircles, a semicircle going this way and a semicircle going this way. Okay, now if you notice, the angle measurement for a line is 180 degrees, so that means that this out here is going to be 180 degrees. And this over here is going to be 180 degrees, which makes sense because it divides into two equal parts. Okay. Alright, so that's what we're talking about with this. Okay, now what if I accidentally just draw out from the center, not going through to the other side, but just from the center to the edge? That will be called a radius. Okay, so we'll call this a D for diameter, and this one a radius right here. Okay. Let me see what else did we get. Okay. Now the central angle, and let's say that we have something like this right here. Let's say that this is our central angle that we're looking at. Central angle just means it's an angle centered at the center. So let's say that this one would be about 60 degrees. Okay. So a central angle is just going to be right in there. So that one's pretty simple. Okay. Now if I draw over here another angle that is also 60 degrees, then those are congruent angles. Congruent central angles. Okay, now if you notice, they're definitely not going to be definition over there, but I'm going to get there in a sec. Okay. Alright, so first off, let's take care of the majority of the definitions. Okay. Alright, now if I have two circles with the same center, okay, that is called concentric circles. Okay, so they both have the same center. So in other words, this one has one radius and this bigger one has a bigger radius. Okay, but they both share the same center. Okay, so that's concentric circles. Okay, now what if I measure the distance around the outside of the circle? Okay, that distance is called circumference, and we call that this formula, circumference equals 2, and it's going to lead me to my next discussion, 2 times pi times the radius, or pi times the diameter. Okay. Alright, now pi is actually a number that is derived from the fact that if you take the circumference of any circle and divide it by its diameter, you will get pi. You'll get a number that's really close to pi. So that's some really interesting stuff right there to understand where pi actually comes from. Okay, now I'm done talked about this quite a bit. Let's start talking about naming some points on the edge of the circle and start talking about what shapes they make. Okay, now what shapes they make are actually really kind of cool. They make some things called arcs. Okay, so from DC to CA to AB to BD, those are arcs. Okay. Alright, now arcs are just the measurements of the edges of the circles. Okay. Alright, now a minor arc would be something like DC. So this would be minor. Okay. So this will be a minor arc. Whereas if I used a whole bunch of it, okay, that would be called a major arc. And a major arc is usually bigger than a semicircle. Okay, now a minor arc would be something like this. It would be DC, and then we would mark with our pencil a little arc-like measurement. Okay, now the major arc back here, we could use any combinations of letters, but you usually want to use 3. So like D, A, C. And it usually tells you the direction that you're going, okay? Right? And so you draw your little arc measurement, and voila, you have your major arc right there. Now here's the cool thing is arc measurements equals central angles. Okay? Alright? So in other words, this right here, if DOC, angle DOC is 60 degrees, then the arc measurement is also 60 degrees. Okay? Same thing here. So if this is 60, this is also 60. Alright? Now the cool thing is that means that those are congruent arcs. Okay? So something pretty simple, straight up right there. Alright, now adjacent arcs are going to be arcs that are right next to each other. So like CA and CD are going to be adjacent arcs, whereas DC and BA are not adjacent arcs. And they should share a point when they're adjacent, okay? Alright, now congruent circles are going to be circles that have the same radius. So please understand that all you need is the same radius, and you're dealing with a congruent circle. Okay. Alright, now what I'm aiming to do is try to go for the world record to cram as much information into one slide as possible. So let's go ahead and go back a little bit. Alright, let me get rid of some of these bad boys right here. There we go. Okay, so now let's say we do know that this is 60 degrees and this is 60 degrees. Okay, now what I'm going to ask you to do is to be able to find arc AC and arc DB. Okay, well arc DB is pretty much the easiest. That's going to be 180 degrees. That's going to be the arc measurement. Okay, so that's pretty simple. Now what about this one in here, arc CA? Well, we know that DB is a diameter. So if DB is diameter and DC and CA and BA are all along the same semicircle side, then all three of these have to add up to 180. Now, if these two add up to 160, if these two add up to 120, which 60 plus 60 does, that means that this is left over with 60 as well. So this will be 60 degrees as well, just by using some pretty ingenious facts of just working with central angles and everything in between. Okay. All right. So arc measurements, are they going to be the easiest? Not really. Okay. For example, if I had a circle that looked like this, and let's say that I had this right here. Okay. And let's say, let me see, let's make this 50. Okay, so if this is 50 degrees right here, alright, how do I find the rest of that arc? Okay, so now the arc is usually listed like this. It'll be arc, let's call this A, B, and C. So if I wanted to find arc ACB, okay, I would just go 360 minus 50, which would be about 310. Okay, and that's the cool thing about that, is that you can actually use the knowledge that this entire thing needs to add up to 360. So I can subtract at least 50, and if I had several others, I could minus those and be able to figure those out. Okay. Okay, so let's say we were dealing with something like this. We had a circle with a radius of about 12 inches, and then we cut in a sector of 110 degrees. Okay, now the circumference would be pretty easy to find. It is just pi times the diameter, or 2 pi times the radius. Okay, and in this case our radius is 12, so this actually turns out to be 24 pi inches long. Okay, now you're probably asking yourself, whoa, why don't we do that pi times 24? You can, but it's going to get you an approximate answer. I would just say leave it as is, but if you'd like to convert it, it's going to be 75.39 inches. Okay, remember, because this is circumference, okay, we don't want to give put any squares or any cubes on the units, because we're just dealing with length, and remember, it's just the length around the outside. Okay, I like this one right here, 24 pi inches, just because that's an exact measurement. This one right here, not as exact. It just depends on what the question's asking you. So if it's asking you for exact answers in pi units, you would just deal with it as is, and just keep pi as just like an x or a y or some kind of variable. Okay, now if I needed to find the arc length, okay, of the same circle, all right, what I would do is I would take the percentage of the actual angle in the middle, okay, in the exact formula. Let me get it for you real fast. Is the central angle, oops, let's try it in there, is the central angle that you're working with, and you're going to divide that by 360 degrees, okay, which makes sense. Right? Now that's the percentage of the circle. So this is the percentage of the circle. Oops, let's get rid of that. I did not need that extra one. This is the actual percentage of the circle. So that's the percentage of the circle that we are using. So, okay, we are going to take that percentage and times it by the actual circumference. So that is going to be 2 pi r. Okay, now in this case we already know it's 24 pi, and we can start plugging in numbers and just working with it as is. So this is going to be 110 divided by 360, all right, times 24 pi inches. Okay, now what's going to happen is the degrees cancel out, and I'm left with, I believe this is just 11 over 36 times 24 pi. Okay. Now if I treat that as 24 pi over 1, I can just multiply straight across, and I would just get, let me see, 264 pi units over 36. Oops. And you can spell pi too if you want, over 36. Now if I reduce that, 264 divided by 36, that should reduce to 22 pi divided by 3 inches. Okay, so long story short, the entire circumference around the circle is 24 pi. The entire circumference from here to here of the circle is going to be 22 pi divided by 3 for exactness. Okay, once again, you can get approximate numbers and get those decimals, but I wouldn't recommend it, okay? Alright, that's it for working with circles and arcs. I'll talk to you later. Bye.